Hello friends, this is Neeraj here again and I'm super excited for this new module which I'm going to talk about it today, that is HVAC discipline interface challenges, which is a part of this mega course. When I've selected this particular topic, then I realized that this topic is going to add a lot of value when you actually start working in your day-to-day life with this particular knowledge. When you see you are an HVAC engineer and currently also you might be working in a contracting company, and in contracting company also you may have to, if you are working on site also, you may have to interface with the architectural department, then the instrumentation department, then client, then of course the civil department. So these are the disciplines basically you need to interact with it. They may be subcontracted, they may be within your company, but still you have to coordinate with them. Like architectural department is there, or interior department is there. It may be a architecture side. So there are various agencies you call between. So you have to speak to them and coordinate, and you have to get your things done. During this process also, it is quite possible that you might have to give your inputs to them or receive the inputs from them so that you can incorporate in your site work or in the design, and you can move forward as a team. So same thing applies to oil and gas also. In oil and gas also there are various disciplines to whom you need to coordinate on day-to-day basis, receive the inputs and give the inputs. But of course these disciplines are far different than the building industry. Offshore disciplines are we call the name very differently. Some disciplines are totally different. So what are those disciplines and what are inputs we need to give it to them, and what are the inputs we need to receive from them? This is very important for the smooth function. Otherwise, what happens is all about blame game. No, they will start putting the blame on you. You will take the blame, and other you have to put the blame on others. But ultimately, the project doesn't move. It's not good for the project. So, to have a proper design, you need to have proper functioning. Definitely, if you work as a team, it is very effective. So, this particular model, I'm sure that nowhere in the world this kind of things are covered. I'm 200% sure, being in industry for so long. So this is going to give a very interesting insight of the other disciplines and their roles, the success of HVAC, and role of HVAC in their success is captured in this. So just listen very carefully. Let's move to the next slide. Certainly you guys must be laughing, what is this all about and why this photo is there and why the photos of these Backstreet boys are here doing. So there's an interesting thing. I want to make it very interesting. So whenever the name of HVAC comes in the oil and gas sectors, all other disciplines behave as if we are something strange people, who we are, what we do, where we do, as long as don't mess up with our interfaces or things like that. So this is what the people in the oil and gas industry look at us. So you have to be prepared with that. It will you may feel once you enter into this field, you will feel this difference. They don't consider us to that level, but that's the whole thing. That because it's very challenging, and they feel that whether we can these HVC guys can cope up to this challenge. Are they technically fit to answer us? Are they technically fit to face us? So this is what the HVAC feels is very exciting. So that you have to be on your toes always, and technically you have to be very strong in the meetings, because you cannot imagine the kind of grilling happens in the meeting, and clients literally tears you apart even if he sees you that you are not confident or you are a little bit shakeable. Other disciplines will come and literally they will tear you apart and throw. So that don't worry, but that is what here I am for you, to give my entire experience to you. So you should not be scared. You just have to face it. People will look at you very differently. People will try to judge you being incompetent HVAC, what they do and stuff like that. They will make you feel inferior. They will feel that they are the only one who have technical knowledge and being smart. But remember that you have to be confident, and to give that confidence, I am there with you. So this is just a fun element I have added to make you feel that yeah, this is what you have to face, and how to handle it, I will teach you. And this no other course will teach you. I am here for you and I will teach you. That's my promise. Let's move to the next one. Okay, how we are perceived in the commercial residential sector is like this. When the building is there, of course, without HVAC, a building cannot perform. So we get our due respect over there. But as long as oil and gas is concerned, we have been perceived like this, like an alien. Like, what are they doing over here? They have to just cool the space, that's it, and they have to cool the space and go. What we have to do, what inputs we have to give. This is how the general attitude of other disciplines. They don't understand unless until we come into picture and we start taking actions. Then only they realize. Most of the times we face neglections at the initial phase. But as and when we have to give the confidence to them that yeah, we are cope up, this is what the inputs we need. We have to be aggressive towards the input, how to ask the inputs, how to receive the inputs, everything I will teach you. So that from the day one, you will, whenever you get the charge of the project, you can handle it very, very well. All the tips I will give to you for that. So that it's not only about the theory course or a PPT reading kind of a course. I'm going to give you some practical examples also, practical language also, how to speak, practical case studies also, drawings, everything, technical, practical projects, whatever I have done, I'll just share it with you so that you be ready from the day one of the job. So this is again one of the fun element that we have been perceived like this alien, but in actual building sector, commercial sector, in the land jobs, wherever you are executing currently, we are like a Superman. We get that respect. So this is all I wish to convey to you. Let's move to the next slide. In this particular slide, if you are talking about the various other disciplines which are the part of oil and gas industry. So this is the process discipline, electrical discipline, instrumentation discipline, technical health safety discipline, or some people call it as a loss prevention discipline also. There's a structural discipline, architectural discipline, and a piping discipline. And each of these disciplines has something to receive from HVAC, or HVAC has to receive something from them. So if you go to the oil and gas offshore sector, these are the main discipline. You have to deal with them. So listen and mug up this name properly, because one by one I'm going to unfold the role of each discipline for the HVAC and vice versa. So these are the names of the discipline which you need to remember. And next slide I'm going to explain you that how each discipline is impacting the HVAC. So let's go to the next slide. Here, if you see this particular slide talks about this interdiscipline interface with the process discipline and HVAC discipline. As far as the process discipline is considered, in HVAC we have to use most of the times the water cooled condensers, maybe water cooled chillers, maybe water cooled chillers also has the water cooled condensers. Then various other places we will be needing the water. So from the sea, you will be asking question that in the middle of the sea, lot of water is available. So it can be used. So what's the problem by HVAC? The problem here is that the the condenser what we are going to use for our chillers or whichever purpose, maybe condensing unit, water cooled condensing unit. For these water cooled condensing, we need a seawater, and seawater has to be come from. So this particular seawater is been delivered to HVAC by the process discipline. What process discipline does is they have their own pumps which takes the seawater, the filtration takes place, processing takes place, dirt gets removed, and that particular water being supplied to our condensers. So water is ample amount there. Seawater has been circulated to us, and we use the seawater for the seawater cooled chiller, seawater cooled condenser wherever the availability is there. So we have to tell them that how much water we need. So what they do there is when they select the particular pump, which is apart from HVAC, serving the seawater to other utilities also, because there could be other utilities. There are a lot of processes happening on the oil and gas platforms which needs a cooling for those equipment. So for that cooling purpose plus HVAC cooling, they take into account and they design the pump plus design the pump head. It is their responsibility, not the HVAC department responsibility. Please remember. So it is our duty to give them what is water quantity needed for the condenser to cool. So they can design the seawater pump for the entire platform. Seawater temperature we need to tell that how much our condenser needs. So once we get the condenser, because once we get the temperature, then we can select our condenser based on that. Second thing is that if you are using pneumatic damper, of course you need air. So air is again a utility. So that particular utility also we need to inform that we need this much amount of air to close or open our damper. So wherever the air compressor is located, which is serving air to various other processes, various other departments, various other machines, the amount of air comes to our dampers also if we are using the pneumatic dampers. So if you see three things here very much essential to deal with the process discipline. One is seawater temperature. We need to get it from them to design our condensers because capacity depends on of course the temperature also, flow also. The second thing is flow. We need to tell them that to cool our condensers how much is the flow required. And third thing is the air requirement for the dampers. So these three things we normally interface with the process discipline. Hope it's clear and let's move to the next one. After this process discipline, we are going to discuss about the interface with the instrument discipline. The instrumentation or instrument and discipline also plays very important role in the oil and gas sector. As I told you in earlier slide, the process plays very vital role because they have to design the entire process for the oil and gas platform, how the oil will come, how the oil will be separated, how the proper oil, crude oil will be formed, how it has to be filtered and all these things, how the mud will be taken, they handle it. When the instrumentation department is there, they also play a very vital role. The instrumentation department has to measure all the quantity of gases, oil, then what are the set points they have. So it is very important for the safety purpose, safety perspective also. So we can measure and we can decide what's happening on the platform. So parameters, whatever are there, that the instrumentation department decides the parameters which can be read either the signal transfer to the PLC or wherever the panel is there that is being taken care by the instrumentation. Now the question is that what is HVAC doing with the instrumentation? So whatever the IO summary, whatever we have that is input output summary, all you might be aware of the IO summary. So IO summary, FNG philosophy, fire and smoke detectors, fire dampers will be hardwired to FNG. This all data we need to coordinate with the instrumentation discipline. This is a very high level kind of a data. We'll going to do much into details in the subsequent modules. But just to give an idea, this is what we need to interface with the instrumentation discipline. We need to install the fire and gas smoke detectors also. Then gas detectors are comes separately because there's H2S gas is very vital. So I'm going to cover subsequent slide what are the measures we need to take while we install our pressure ducting. It should be away from the gas, how it should be kept away from the gas. All these mitigations we will subsequently cover in the modules. So as of now, just remember this. Now let's go to the next one. Here, if you see the electrical discipline plays an extremely important role. As you know, in the building sector also, we have to deal with electrical discipline. Here also, without electrical, our HVAC systems cannot run. So this is the reason HVAC and electrical are like husband-wife. We need to always work together towards a successful completion of project. For that, what we need to do and what inputs are needed from us to them and them to us. Simple thing. There is voltage and frequency. Voltage is essential because 400 volt or 690 volt because 400 volt is LV, low voltage, and it goes to 690 volt, it becomes MV. So selection of motors is different. So we need to always ask them that what is the voltage entire platform you are considering for. It is LV or MV because based on that your entire HVAC system is going to change the electrical aspect. Cabling will change, your transformer will need to add it or motor will need to select differently. and the frequency. So 50 hertz or 60 hertz. Majority of the oil and gas platforms are 99% of the 50 hertz, but still every time you need to ask because surprises are very common in this sector. Why 50 hertz, 60 hertz is important? Because 60 hertz, as you know, the RPM of motor is higher, and 50 hertz is RPM of motor is lower. So of course, if you're selecting a wrong hertz or wrong frequency motor, your output for the motor, maybe it's air or refrigerant, is going to be different, and it may be overcapacity or undercapacity. So selection plays very important role over here. So these are the two things you need to keep in mind. Voltage and frequency, you need to ask them because based on that your equipments are getting selected. Second is heat dissipation. Heat dissipation is of course not in your hand. You have to get the inputs from the electrical because electrical is the one from which the motors are there or the electrical panels are there from which the heat is going to be dissipated from that. Apart from the human heat or the electrical lighting also they need to give what kind of lighting they are using. It's LED, incandescent light or whatever. They need to tell you. So based on that heat dissipation value is also there will be as long as the motors are considered, as long as the electrical panels are considered. Of course, there are certain thumb rules which I'll tell you later if they don't give, but you should push for always these values because if they don't give, you will be in trouble. So you have to always ask for it. Next, what thing we need to ask is the HVAC electrical load. We need to give it to them. Remember, they need to design the electrical panels. They need to design the electrical distribution board. So to design that, they need the electrical load. So tentative calculation for electrical load because you know there to you know this airflow, you know the static, you are a mechanical engineer, you can calculate the shaft power easily. And once you calculate the shaft power, don't worry, I'll give you the formula for that also. Then definitely you can add some contingency and you can divide it by the motor efficiency. So you will get approximate size of a motor, how much kilowatt it is. So losses considering how much motor load, I will teach you how to do that also. Very simple thing, very simple formula. So once you do that, whatever the motor load tentative you arrive, you need to give it to them. Or you don't want to do it, simply approach if you have contacts to any of the AHU vendor, give them a data, he will tell you the motor size what is needed. That is a very simplified and authentic source. But you know at the initial phase of the project, no vendor will entertain you unless you are a big client. So few things you need to do the calculations and always bit oversized things you need to give it to electrical so that afterwards you can easily optimize and give it to him. So this is the electrical load part. Next thing you need to consider is electrical panel specifications. Most of the time what happens is electrical discipline is too busy. So at that time you need to take charge. It happens that project to project, some to project are NOSOC project for that form 4, form 2, form 3. See, there are various types of this electrical panels are there. Form 1, form 2, form 3, form 4. Form 4 is considered as a very stringent and for the North Sea applications, form 4 is being preferred. So being said that here electrical panel also plays very important role. The specification is very important. You need to take care of that also. Then duty standby configuration. One motor is duty, another motor is standby. So those inputs also you need to give it to the electrical discipline. Then comes the requirement of isolators. Detached to start together with electrical and tell that maintenance purpose. You need isolators in each of the major equipment so that if some fault is happening, they will isolate and do the maintenance so that there should not be any hazard or accident. And safety point of view also it's good. Then the damper voltage, it is whether damper is electrical, pneumatic, whether it's 230 volt or 24 volt AC or DC, various types. Dampers comes in various types and configurations. So you need to give this data to the electrical discipline. Then you need to design the shutdown philosophy because suppose something happens on the platform, suppose the gas is detected, fire is detected, then how your control panel or HVAC panel will get closed. That kind of a philosophy you need to sit together with technical safety discipline, electrical discipline, instrument discipline, all major discipline. They have to sit and need to design the entire system shutdown philosophy. Then normal and emergency distribution load also we need to do, because when any emergency happens, your all your staff is go all your crew on the platform is going to take a refuge at particular place that we call it as a temporary refuge, and you need to keep certain equipment running in that case to maintain the cooling for that particular requirement and pressurization for particular zone. In that particular requirement, you don't want your laundry fan to run, you don't want your kitchen fan to run, you don't want your toilet fan to run. You can tolerate those 4 hours without that. So you are reducing the load and you are putting it on the diesel generator, which will run and which will provide the air conditioning, which is just enough for the 4 hours for those people who are gathered at that particular location. So that particular requirement also you need to inform the electrical. Okay, this is the requirement. This is the people are going to stay here, and other things I don't want you to take off the load. So he will account for that particular load only when he's designing his emergency diesel generator. So this also input we need to give it to electrical. So there's a lot of give and take between electrical and us. So we need to keep in mind always. Let's go to the next slide. Well, this is a very interesting one, and you will definitely correlate this particular thing with your day-to-day professional life. In your day-to-day professional life also you might be interacting with the architectural discipline. Why? But a false ceiling, reflected false ceiling plan. Suddenly architect think of a new design like it will go like this false ceiling and you need to move your grills and ducting like that. I'm 200% sure you might be having lot of clashes with the architecture or architect in particular, because your false ceiling and many other things clashes with, or ducting clashes with this false ceiling, and you know what I mean. So here also you are not different. Here also you need to face the architectural clashes, unavoidable. You have to fight with the structural discipline. You need to fight with the architectural discipline for the space, because you are a final HVAC. You can't escape it here too. So here also when you deal with the architecture discipline, space is a major constraint in oil and gas platforms. Very tough. You need to really fight neck to neck with these disciplines for the space. It is not like building sector you have huge space above the false ceiling. It doesn't happen here. Every inch matter. You need to struggle very hard for even 1 mm also. Same for architecture. You need to ask for the H rooms, plant room size, location where I should keep my units, shafts or riser locations and the respective size you need to give it to them. Not only give it, you need to justify those sizes for the rooms and size riser by making tentative drawings. Then your ceiling, false ceiling heights, galley, laundry, heat dissipation, air conditioning requirement, all is the you need to deal with the architectural discipline. Freezer room details, because all freezer rooms of course comes into the this consultant of the architect. He has to design the freezer rooms. Of course, the cooling load and all we have to design, but he need to lay out and all. It is his scope, architect scope. Then room layouts, the space for maintenance provision and material handling, we need to tell him. So we have to fight a lot and we have to give them a lot of inputs so that to justify why we need this much space. Because not only we but other disciplines are also behind the architecture discipline to they want space. So finally they try to bully the HVAC and they try to minimize our space. But we need to have a solid justification that why we need that space. And if we can give that justification, then they keep quiet. Same stories everywhere. Don't worry, you're not different. Architect, you need to fight here also. So this is what with the architecture, same story repeated again. Let's go to the next slide. The THSE or a loss prevention department. THSE is nothing but technical health, safety and environment. This particular department is mandatory in every oil and gas company. This is mandated by government, because unless he approves the thing, things don't proceed. Because this particular discipline takes care that whatever design or whatever things, whatever we're trying to install, are they safe? it is their responsibility, because unless they confirm that it's safe, the process are saved, the locations are safe, the project doesn't move forward. So they design what is the hazardous classification. I'm going to cover it in the next subsequent slide, but it's too confusing. So hazardous area classifications, then various other safety studies they conduct over here, whether processes are safe, whether electrical is safe, whatever instrumentation is safe, HVAC is so safe location intakes are located or not, what will happen if the fire breaks out, what happens if the gas breaks out, what happens if the explosion happens, what is the effect of each system of this particular things, what is the cause and effect diagram in that case, which system will shut down, which system will work. All these pros and cons and effects are being taken care by the technical safety discipline. Now, when it comes with the HVAC, technical safety has to work very, very closely, because it has to deal with humans, human life apart from process, which is much more vital than the process. So when we talk about human, he's talking about the accommodation where people are staying. And he talks about the accommodation, HVAC he cannot avoid. And if HVAC is there, that means again he need to think that whether it will be recirculation or pressurization, because outside gas should not come inside. So how to achieve it, or what the cause and effect we need to decide. So we and the technical safety discipline has to sit together and we need to discuss, okay, fire happens, then HVAC system should work or not, whether the fresh air damper should close or not, whether pressurization should be considered or not, whether the gas leak happens outside the platform, that same thing, whether it should work or not, or it should shut down. That we need to sit, and there are various standards. Again, that we need to compare our philosophy. At the end, we need to see that the humans are safe and humans are comfortable inside. Then the black start philosophy we need to discuss with each other. Black start is suppose your entire platform is shut down and again you need to restart it. Then what are the steps you need to follow? 1, 2, 3, 4, 5, 6. Suppose there's a fire inside the accommodation. Now everything is shut down. After 4 hours, fire is extinguished. Everything is fine. Now what is the next step? So for HVAC, what is the next step? How they will remove the smoke inside, whether the purging will happen or not. That technical safety discipline and HVAC has to sit together and then decide how to manage the smoke inside the accommodation, how to remove it by purging or manual by portable fan. That again we need to discuss with the technical safety. Fire and blast rating of the bulkheads also discussed by the technical safety. Hazardous area classification, zone 0, zone 1, zone 2, safe area. Anyway, don't worry, don't get baffled. I'm going to cover it in subsequent session. It's just for information, because oil and gas platform means you need to consider the leakage of gases also while we are taking out the oil or gas from the respective reservoir. So any gas presence is there or not, my HVAC equipment is located there or not, what will happen if the spark happens, then entire platform will get bursted, right, from the HVAC equipment. So what provisions or precautions we need to take, is there any certification available. So these things also is a part of the hazardous area classification zone equipment designing. Then the temporary refuge philosophy is the place where, as I told you, everyone gathers together in case of emergency. So that is called as temporary refuge. What philosophy we need to design, how pressurization we can maintain, what happens if the pressurization fails, can we provide oxygen cylinders over there for the pressurization purpose. So these are all things we need to sit together and discuss before closing the project or before designing the project. Then hazard workshop is there. Hazard is hazard identification. Hazard is operational hazard. These workshops are the part of the life of the oil and gas professionals like us. Client, that means client comes and grills even the stupidest question he will ask, but you need to answer. He may ask you, what if the pipe bursts due to overpressure? How you have, because he always thinking the worst part, what will happen? Because he's right at his part. Suppose he has to operate the whole plant. So we'll ask those questions and you need to be ready to be with your answer very, very confident. That okay, this happens, that this is a provision being considered. Or our pipe is capable to handle this pressure. Or we have over designed the pipe so that even if the pressure achieved, the pipe will not burst. So this kind of smart answer we need to give to satisfy the client. There are various other safety workshops also for which you need to be the part of it. So always remember that this discipline is very, very interesting. yet challenging. You need to deal with it, and you need to satisfy each and everyone. Like these are the points. Uh, anyway, I'll be covering in the subsequent sessions. They're in detail. There's ISO 15138 big model is there for the offshore platforms. In that, all these things will be anyway covered. But this is just for your information. Let's go to the next slide. Now, next is the structural and piping discipline. For structural, mainly we need to deal with the equipment weight. We need to give it to them because they need to design the structural support, foundations. So without they get our equipment weight, they cannot provide the foundation for us, right? They have to do analysis for the whole platform. So for that, weights of the HVAC equipment are also necessary. So we need to provide the weights. We need to provide the foundation footprints. And remember, these on oil and gas platform, there is no concrete platform. No, for oil and gas platform is the steel structure is there. So steel is there and steel foundation is welded over the steel. So you will not find any concrete over there. It's a steel to steel business. Entire oil and gas platform is a steel, not stainless steel. It's a proper steel. Stainless steel also there, but it's not. Your accommodation stainless steel, but it's not here. It normally happens at the North Sea locations, not here. No, or not other part of the world or Middle East. Middle East is steel, carbon steel. So external pipe, duct supports, beam heights, penetration details, these are the part of the structural interface with the HVAC. Of course, we need beam heights because our duct has to pass below the beam between the false ceiling. So we need to always be concerned about the beam heights. Penetration details also I will cover in next sector. We need to have a steel penetration when we are penetrating any bulkhead. Bulkhead means wall. It is steel wall. So penetration details I will cover in subsequent session. So these are the we need to into the interface with the structural discipline. As far as piping discipline is concerned, we don't have much to do with them, but they are the discipline. Interestingly, they prepare the plot plan. It is room layout. Yeah, you may hear it quite strange, but piping discipline prepares the room layout, and they do the 3D modeling also. So while do the 3D modeling, of course, we need to give them the inputs about HVAC ducts and all, so they can be routing their pipes below or above the duct wherever the space is there. So that's the role of the limited role is there for the piping and HVAC, but as long as the disciplines interface is considered, they are also important. So let's move to the next slide. So in short, you have seen various disciplines working together, that is process, structural, piping, electrical instrumentation, HVAC, technical safety, mechanical, all we need to deal with them, but at the end of the day, to make a project successful, we need to be stronger together, we need to come together, interact with each other without blame game, and provide the inputs to each other. And that's the key of a, and don't consider anyone inferior. Nobody is inferior. All departments are equal. If your project manager is good, if your project manager is smart, if he's giving fair opportunity to everyone, all discipline are treating is equal. So if we come together, definitely we are the team. And when we are team, we perform in a much better way towards the proper execution and successful completion of the project. So always remember, you are not inferior, you are not a weakest link. You need to be strong, and if you perform as a team, you will definitely win in the project. That's it. That's the end of this module, and let's go to the next one. Hope you enjoyed this and learned many new things.